Okay, so let's talk about what we saw before in that experiment. What we saw was that when we heated up the resistor, it actually caused an increase in voltage or a drop in resistivity of the resistor. Now that is not what we were expecting. We were expecting to see a drop in voltage and an increase in resistivity. Now, the reason for this change is actually based on the atomic level. What happens when we heat up the resistor is that the atoms begin to move more violently, and that begins to shake off more electrons into the outer shells, which causes them to become free electrons, which allows them to carry a current better. So basically what we have before it's heated is an atom with a couple of electrons flying around like this, and that isn't really a lot to carry a current as compared to, say, a conductor, which could have many electrons flying around, which can easily carry a current. But what happens as we start to heat this guy up is that this nucleus starts vibrating more violently, which starts to kick off some more electrons. And each one of these electrons gradually decreases the resistivity inside the resistor itself. So overall, what we get from an increase in temperature is an increase in voltage and a decrease in resistivity. Now this is opposed to what happens in a conductor, which has many electrons already. What happens in a conductor is that as the atom gets excited, these electrons start flying around at increasingly greater speeds, and as they do that, they start to crash into the nucleus, or start crashing into some of the more tightly bound electrons and start to cause them to kick off, and each one of these collisions takes up energy from the electron, which creates resistance.